Welcome back, everyone. What we have here is my personal TurboGrafx-16. We're going to do just a little bit of testing on here because TurboGrafx-16 and the PC engine both like to run really hot because the voltage regulator. So we're going to see what we can do about making it not run so hot. And if you can see on here, the OEM power adapter, we have output of 10.5 volts DC, 730 milliamps. We're going to start by taking this apart and getting a baseline reading on here. And I will explain that as we go. So we'll start by flipping this over. And then these have everyone's favorite game bits in there. These have 7 of the 4.5 millimeter game bits on the bottom. So we'll just get all of these removed. Okay, we have unscrewed all of those. Let's see if they all fall out. That looks like 7 of them. Then we will remove our little adapter. I don't know if it needs to be popped off to take this apart, but just to be safe. Okay, and then the bottom falls right out. It's funny part, that's all supposed to be soldered down, but it actually looks like those have all already been popped up. I see a screw up here. Yeah, I've not taken the system apart before, so this is a good learning experience. But someone else has been in here because of solder points like down here just being kind of ripped up off the board. We'll go ahead and remove these 2 screws right here, both Phillips. Okay, and then we'll try to pop this part out of here. There we go, just enough to get these screws undone. We can get the whole board removed, but I'm not that worried about doing that because I kind of want to check out what is under this. Okay, and then that just lifts up. Oh, that does not look good there. Well, the system works, but that is concerning. So at some point, someone had this board open. If you saw the Turbo Duo video, you know that they definitely like to have solder holding things down. On here, you have this spot. You have these 2 spots here. You have this one back here. This one over here. This one here. This one here. One back here. And all of them have been ripped off the board. You can see over here that pad was just ripped off. So someone was in here and did stuff in here and did not remove those. It's actually kind of sad to see. So if you're taking one of these apart, then just remember there are all these little solder spots along. Do not rip that up. I'll do a quick spray out with a can of air. I actually got this system before I got into all of the retro console repair. So I never even took this one apart to clean inside or anything. I just kind of trusted that it was done already. But it's not that bad inside. I don't know if I'll be able to fix those spots, but I can see if I can get some solder when I put the shield back on for those. But that's not the point of this video. Now this is the beast right here that causes a whole bunch of heat in the system. It's our 7805 voltage regulator. So there is a range. These voltage regulators can get up to about 35 volts, but I would not recommend going any higher than what the regular power adapter has at that 10.5 volts. And what I did for testing, we have the OEM power adapter, and then from DigiKey I ordered a 9 volt one, and then we're also going to try a 7.5 volt one, because based on the specifications of the 7805, there's about a 2 voltage dropout on it. So theoretically you could use 7 volts, but I picked 7.5 for this because I couldn't find a 7 volt one to test. I did read online though that they wouldn't recommend 7 volts just in case there's slight fluctuations in the power. There's a chance that directly using 7 volts might cause some distortions or other weird stuff like that. I'm actually going to install these 2 long screws back here with the accessory slot on the back, just to help stabilize that a bit. And then install our little Hyperkin adapter, because by default this just has component out. Definitely want to be using these days. Get that pushed in there. Okay, we have that in place. Then we'll get all of our cords hooked up now. We have video cords. We have the 10.5 volt power supply. And we have our controller. Then we'll grab our game Newtopia. This is pretty much Legend of Zelda for TurboGrafx-16. Since this is upside down, we will just put that like that. And then we have our fun little toy setup right there. So we're going to see what the temperature gets to. This will probably be over the course of a couple days of me recording because I want to make sure the system is cooled down before I start the next one. But I want to get what the base one is with the OEM power supply at the moment. So I'll get the game window up, grab the controller, and I'm going to do probably around 30 minutes of gameplay just to make sure everything's heated up really well.
Let's see the show. Newtopia's calling. Gotta save the land. Controller in my grip, power in my hand. Feel that heat, it's rising. Oh, it's real. Voltage regulator, tell me what's the deal? Turbo heat, yeah, it's burning hot. Burning. Voltage regulator, giving all it's got. We're dancing now to that pixel beat. TurboGrafx jamming. Can you feel the heat?
This is VoiceOver Gumptendo. Nice to meet you. So the past Gumptendo that was recording this was kind of a big dum-dum and forgot to unmute the microphone after recording all the gameplay. So what we're looking at here is the temperature of the voltage regulator. So you see 106, 105, looking at the chips, and these are in degrees Fahrenheit that we're using on this. So you can kind of see the different chips on there, their different temperatures. So this might help at some point if you ever needed to troubleshoot a system and see what temperature things needed to be at. Oh, there we go. There's 108.1, 108.3. So it definitely does get up there a decent chunk in temperature compared to the room temperature, which in here it's usually about 68, 69 degrees. Now everything is cooled off on here, as you can see on the camera. So what we're going to do is use our new power adapter here. This one is 9 volts as opposed to the 10.5 volt one. Now you can use the Sega Master System or the Sega Genesis 1 power adapters. Both of those will work fine on this, but these are a little less bulky than the stock ones, so I ordered these through DigiKey. I can actually show how to search for power adapters for this through DigiKey or other places after we're finished testing these. So we have the power adapter plugged in. I will plug it on into the system now. Help if I tried plugging into the right side. I'm used to the system being the other way, where the plug would be on that side. Okay, we have that plugged in, and then it will be time to turn it on and start playing the game some more.
Dungeon crawling, enemies beware. Treasure in my sights, it's a digital affair. Fingers tapping, rhythm in my flow. But the regulator's sweating like it's in a show. It's glowing, it's smoking, don't let it quit. Don't quit. This funky hardware's got that retro grit. Turbo heat, yeah, it's the heat.
So then if we take a look at this, we're around like the 107 or 106 or so for the 10.5 volt one. So on here, I mean, that's a significant difference. We're down to about 93 degrees. 88, so yeah. Things over here are definitely running a lot lower of a temperature when it's even just dropped down from a 10.5 to a 9 volt. So now to turn this off and let it cool down and then record with the next one, which will be 7.5 volts. Now the rectangle for the thermal camera might look a little different. Android Studio decided to have an update, and that's actually coming from my phone, so it's yeah, the update kind of had to readjust some things on here, but I think I have that good now. So on to our next fun thing here. We have our other power adapter. I can figure out how to open this box. Must have an IQ at least 5 points higher than the object you're working with. And this is our 7.5 volt power supply. And this one gives 1 amp. We will talk a little bit about the amps after all this stuff's done. But for now, I will get this all plugged in. I tried to plug it to the other side once again. Now I know it only takes probably about a minute or two to actually get up to the temperature that we're wanting to see on here. But this gives me an excuse to play this game a little bit. I haven't played this game enough and it's a lot of fun. So then I will get this turned on and then we will check that out.
Turbo heat, yeah, it's burning hot, burning. Voltage regulator, giving all it's got, all it's got. We're dancing now to that pixel beat. TurboGrafx jamming, can you feel the?
So now let's check out that temperature. That's around 87, looks like it's peaking at. But if you notice, compared to the other ones, this whole section over here was always heated up quite a bit. But now with this lower one, it's definitely not doing that. So we showed the temperature differences between those three power adapters, but there's one more thing that I'm wanting to test out here. Just kind of doing a proof of concept of USB-C on here. We have some USB-C breakout chips here. And what we're going to do, I have the 7.5 volt adapter in here. So I'm going to grab our multimeter, going to set it to the 20 volt setting on there. Then we're going to figure out a few things on here. So our voltage regulator, the center one's going to be ground, so I'm just going to ground out on there. And then I'm going to see which one of these legs has the power coming through. Okay, so the top one has power. Middle one on here has nothing. And the bottom one has nothing. So that's coming in from the power adapter. The top one is the only one that has power that comes through. So then if we turn the system on, I'll still ground out on the voltage regulator here, but we have 6.69 volts going in through there, and then coming out 5.05. That's still the 7.62 in there. So then we'll check some of these. So this diode down here, 6.82 on that side, 7.6. So it's losing some power through this diode, which is kind of like what we got to experience with the Sega Master System. Get our system powered off and unplugged. One more thing I want to check out. Moving to the diode area, hitting that for doing a little bit of tracing on here. We'll make sure that ground is... Okay, the ground is connected on the bottom one here. So that is perfect. We have everything we need to test this out. So I grab some wires here. Okay, gonna get a decent length of the black cable right here. The ends of here opened up a little bit, so we can actually use this. Then I'll twist these up, and we have that one is ready. I'll also do a long one for the red one. Trim off the little silicone around it so we can twist up the wire and use it. So we have those wires, and trim off another shorter one for the black wire, and then get the silicone trimmed away on that also. So we have 3 little wires right here. I'll get my goggles on, turn on our fume extractor. So it might be a little loud, but don't want to breathe in any of this junk. Grab our 3 wires. I'll just move this box out of the way. I'm just setting up this proof of concept just to see what it would take to get this in place. So it's going to be something that I can easily remove from here. So this diode down here, we have our diode right here, going to add a little bit of solder to the exit part of the diode. So get that solder on the leg. Okay, have a little glob on there. And then we're going to take our red wire and attach it into that solder. Keep that up, get that wire in there, and it's attached. Then our little power board. Get that lifted up out of there. And it's the bottom leg of it is the one that's grounded out. Going to add a little bit of extra solder to it. That should be enough. Then we'll put our long black cable on there. Okay, that seems good. And then our other cable, I'll get this moved up here. So we can see our voltage regulator down there. Going to add a little bit of solder to each of the outer legs of it. Then what we want to do is take our other black wire and then attach each of the legs to those outer legs where we just added the solder. So get this right down in here. Because what we're doing is bypassing the voltage regulator. Okay, we have that leg done. Okay, that leg is done. Then we'll take one of our USB-C breakouts. And on these chips, we have ground is the second one. Put a little pad under there. I'm going to add a little bit of solder to ground on there. Get a nice glob on there just so it's easy to hook up on there. And then V-bus is where our power will go, so let's put a nice little glob on there. There we go, that's a nice glob. Now some of the USB-C breakouts, you do require a 5.1 kilo ohm resistor to go between, you have CC2, CC1, and ground. But these ones, they're from Amazon. They're bought them in bulk. It's like end up being around $1 each or so. But these already have the resistors built in on the side, so you don't need to ground those ones out. So then to finish this setup here, we'll take our red wire and then hook it to the V-bus on here. There we go, that looks good. And then we'll get our grounding cable hooked up on here. Let's heat that up. There, we have those two cables hooked up. Turn off the loud fan here. Before doing any of this, I want to do a little bit of path tracing again. I'm going to make sure this ground goes to here from, let me zoom out. Okay, so we have the ground from here still goes to here, and then make sure it connects to here also. Okay, so we have our ground looks good. And then this one will connect to the V-bus. And then we'll make sure our voltage regulator is bridged through. Okay. So then I think we should be good to test this out. I'm going to set this on 20 volts. Get our little retro screen up here and plug this in and hope nothing explodes. Okay, that's plugged in. So I'm going to check the voltage now. We know where our ground is over here. So that's good. That will still be nothing. We should have... Okay, we have 5 volts there, so that's good. And then let's turn this on and see what happens. Hey, we have our game. Now there is that random screen flickering that's happening. At first I thought it was capacitors going on the system, but that's actually the little device that I use for converting AV to HDMI is having issues. Just going to hop in here really fast and start this game out. Turn this off and turn it back on here. Get to the nice little title screen again. Now when you have something that's connected with USB-C like that, it actually completely bypasses the voltage regulator. So there's like no heat given off by that. So all the heat is just on all those chips. So I'll go ahead and get this all turned off and then we can finish everything up here. I will be removing these from here, but one of the things when I do go through and convert this to USB-C, the voltage regulator will be completely taken out, and then the first and the third legs on there will be completely bridged over. Power outlet will be removed and replaced with some sort of way of making it so USB-C can nicely fit in the side over here. But I still want the power slot to be over here. I just want it to be a nice modified USB-C one. And then this diode is going to be removed. Everything will be hooked up directly through here. Then as far as each of the results that we have here for the 10.5 volt one, that one got up to 108.5 degrees Fahrenheit. For the 9 volt one, that one was 92.7 degrees Fahrenheit. And then the 7.5 volt one was 87.7 degrees Fahrenheit. So there is a pretty decent difference in the temperature ratings on there. But then the next issue, where do you get some of these other ones to use on here? Because these ones are brand new ones. These are not marketed towards the TurboGrafx. So these are ones that I specially ordered through DigiKey. Now when you go to a site like DigiKey, if you go under products, you can find power on there and then power supplies. You just click on power supplies. We want AC/DC desktop wall power adapters. So then from here, the most important things to do, keep scrolling on over, you have polarization. You want to have center negative for this. So you choose negative center. Of course, right away that limits the amount of things down to 268. And then the barrel plug size. That'd be the output connector. This one is 5.5 millimeters by 2.1 millimeters. So right here we have one, and we'll just do a search in here. Let's look for 5.5 millimeters. There's some of the kits for them. So there are a whole bunch of different ones on here. So if we just click on one of those and then move over here, we want to get to the amperage. So the current output max. Now I know the current is usually 730 milliamps for the TurboGrafx-16, but one of the things with amperage, you can always do a little bit extra. I'd say go with at least 1 amp. Then when you apply that, and you look down here, you have the options of, for that specific one, you can get the 7.5 volts with 1 amp out, which this is actually the exact one that I was using to test in the video. One of the pretty important things when you're choosing some of these, there are some you can get pretty cheap from places like China, but when you go to the data sheet on here, when you are getting some of the power adapters that are lower, like this 7.5 volts, since the voltage regulator is 5 volts and needs to have at least 7 going into it, you want to make sure that regulation and ripple and noise are pretty low numbers. Some of the power adapters that aren't as good of quality that you can order for it will have those a little higher, and that could cause issues to make it so the system isn't going to work correctly. So if you're going for a cheaper power adapter, I'd go with one of the 9 volt ones. So I've done a lot of research trying to figure out for our friends across the pond in the UK and in the rest of Europe what places can be used for ordering, kind of like how we have DigiKey here. I haven't had any luck finding that yet, so if you can let me know in the comments, then maybe I can add some links in the comments also. I found a few places where they offer the US and Japanese versions of some of these, but haven't found any with the other types of connectors. Well, this is kind of awkward, so this is the third Gumtendo you're getting to experience. This is editing Gumtendo. So one thing that I noticed when going back through here and editing things was when the 7.5 volt power adapter was plugged in, that diode was bringing it down to under 7 volts going to the voltage regulator. Because that diode bringing the voltage down, there could be issues. Now, if it's like the Sega Master System, other countries like in Europe and everywhere won't have that extra diode, but in North America they do, at least from the ones that I have seen. So there's a chance that the PC engine might not have that diode, but if you are trying to find a different adapter in the US, then you may want to stick with the minimum of 8 volts. So probably 9 volts would be a perfect one just to kind of help it stay a little cooler. So if you enjoyed this and found this helpful, then please be sure to subscribe, leave a thumbs up, all that kind of fun stuff. I will be making a video in the future converting a TurboGrafx-16 to USB-C. But another thing I do have to research a bit is we have the blue cable, which I believe is an accessory cable. And something will have to be figured out with that. If you have any questions or anything about this, then let me know in the comments also. I want to thank you for watching. Have a nice day.
Thanks for watching our show today. We hope you smiled along the way. From pixel dreams to jokes we play. Like and subscribe, it's the thing to do. Join the crew, red, white, and blue. Gumtendo's here.